function f is such that fx equals 3 upon 2x plus 5. For x is an element of real numbers and x cannot be equals to minus 2.5. Obtain an expression for f prime x. That means the derivative of x, fx. So fx is 3. If I bring up the denominator, it becomes 3x, 2x plus 5 power minus 1. Okay. Now I'm going to derivate this. The minus 1 will come down, get multiplied with minus 3. Then the power gets reduced by 1, so minus 2. And then we multiply the derivative of 2x plus 5, which is 2 outside. So the derivative is minus 6, 2x plus 5 power minus 2. And I'm going to take this in the denominator. So 2x plus 5 squared in the denominator. This is the value of f prime x, or the derivative of fx. Okay. It says, and explain why this is a decreasing function. The decreasing function is when f prime x is negative, less than 0. Is this always negative for every value of x? Yes, it is, because if x is positive, because of minus 6, this stays negative. And even if x is negative, the whole square on it makes it positive, and then the minus 6 at the top keeps it negative. So no matter what is the value of x, this always stays negative. So you write less than 0 for all x. So that's why it's always a decreasing function. Hence, decreasing function. Okay. Next part says, obtain an expression for f inverse of x. Okay, we've done this in O levels. This is so easy. Equate it to y and then make x the subject. This is supposed to be 3. Okay, so for part 2, y equals 3 upon 2x plus 5. To make y the subject, I'm going to swap the places of y and 2x plus 5, sending the 5 to the other side. Now you may take LCM here. That's an optional step though. So 3 minus 5y upon y, and send the 2 here. So the inverse is this 3 minus, replace the y with x. This would be the expression for f inverse of x. Even this would work. If you don't take LCM here, then you take 2 here, so you get a 2 here separately and a 2 here separately. This would also be a good enough answer, as long as you change the y to x. Okay. Next part is integration. A curve has equation y is equals to fx. Find the volume when the region bounded by the curve, the x coordinate, and the line x is equals to 2 is rotated about 360 degree about the x-axis. So we write pi outside. We integrate within the given limits. It starts from the x-axis, goes till x is equals to 2. So 0 to 2. And then we square the function. The function is 3 upon 2x plus 5 squared. This is the formula for volume of revolution about the x-axis. Okay, going to expand. I'm going to square that. Oops. Okay, so 3 square would be 9. I'm bringing out the 9. 0 to 2, there's a 1 here, and then we have 2x plus 5 whole squared dx. You will not open the brackets. Do not use the identity. Instead, bring that up. And now we're going to integrate that. I hope you remember from class that integration of fx power n is fx n plus 1 upon n plus 1 times f prime x. So we have 2x plus 5. N plus 1 would be negative 2 plus 1, which would be negative 1. And in the denominator, we'll also write negative 2 plus 1, which is negative 1, times f prime x, which is the derivative of this. That's 2. So after simplifying, and also there is 9 pi outside, and here we plug in the limits, which are 2 and 0. So we have 9 pi, and we have minus 2 in the denominator. I'm bringing that out. That becomes minus 9 upon 2 here. and I am bringing the bracket back to the denominator so that the power becomes 1. So I have minus 9 pi by 2 and 1 upon 2x plus 5. Okay, now we substitute the limits 2 and 0. Yes, so minus 9 pi by 2, substituting 2, we get 1 over 9. 2 times 2, 4, 4 plus 5, 9, minus 1 upon, when we substitute 0, we just get 1 over 5. Okay, enter this in the calculator and you would get minus 9 by 2. I'm ignoring the pi for now. Times bracket 1 by 9 minus 1 by 5. That gives 2 by 5. And attach a pi to it. This is the volume of revolution.